Hello, in this video I'm going to be showing you how to solve some different types of radical equations. And the first example right here, what we have to do is isolate one of the radicals. That's easier. Instead of trying to square both sides as it is, it's a lot more work. It gets pretty complicated. But if we just isolate one radical by adding the square root of x plus 8 on both sides, we're going to get 4x minus 4 equal to the square root of x plus 8. Now, to cancel one of the radicals, to cancel the square root, we have to raise both sides to the second power. Well, luckily both of these radicals get canceled, and we just get x minus 4 equals x plus 8. And the way we solve this linear equation that we're left with, all we have to do is move all the x's to one side and all the numbers to the other side. We're going to get the 3x equals 12, which means x equals 4. To check this, all we have to do is substitute that x into the original problem. I'm going to do it right here on the side, and then I'm going to have to erase it in order for me to do example 2. But this is what we do to check. This 4 times 4 minus 4 minus 4 plus 8. We're going to check if that gives a 0. Well, the square root of 16 minus 4 is the same thing as the square root of 12. And the square root of 12 if you add 4 plus 8. And of course, a radical minus itself is 0. So it checks. It means that x equals 4 is a solution. Okay, so go ahead and stop the video, pause it at this point, and copy this down on your notes. I'm going to have to erase the check part in order for me to be able to do example number 2. Okay, now let's go ahead and solve example number 2. Notice how the radicals are already by themselves, are isolated, one on each side. So all we have to do is get rid of that cubic root by raising both sides to the third power, leaving us with 4x minus 1 equal to 6x plus 5. Moving all the variables to one side and all the numbers to the other side, we're going to get that 2x is equal to negative 6, telling us that x equals negative 3 if we divide by 2 on both sides. I'll leave the check part to you at this point. All you have to do is substitute negative 3 on each of the variables on the original equation, and then hopefully the left side equals the right side, but I'm very positive it is. To solve example number 3, we're going to start by isolating the expression with the rational exponent. In other words, we're going to isolate this. In order for us to isolate that, we would have to multiply both sides by 2. And by the way, this is supposed to be a 16 in the original problem. I apologize. And so we get x to the 5 halves equals 32. Now, to cancel that exponent, we could do it in 2 steps, or we could just do it in 1 step. Whenever you multiply a number like 5 halves times its reciprocal, the reciprocal is 2 over 5. And if we ever multiply a number by its reciprocal, we always get 1 as an answer. So when I raise this to the power of 2/5 and to the powers of 2/5 on the other side, on the left side we just get an x, and 32 to the 2/5 is the same thing as the 5th root of 32 to the second power, which is 2 squared, which turns out the answer is 4. And that's how we do that. Okay, example number 4 is very similar, but we're going to isolate the expression with the rational exponent. So we're going to subtract 28 from both sides. 6x plus 10 to the 7 halves is equal to 128. 156 minus 28 is 128. And we're going to do something very similar. We're going to raise both sides to the power of the reciprocal, which is 2 over 7. Again, we do that because 2 over 7 times times 7 over 2 is equal to 1. So it's going to give us 6x plus 10 to the power of 1. And this is the 7th root of 128 to the second power. The 7th root of 128 happens to be 2, and 2 squared makes 4. So now we could solve for x fairly easy. Subtract 10 from both sides, you get x. 6x equals -6, which means that x is equal to -1. Okay, so -1 is the answer at this point. All right, please pause this video and copy it if you need to. The next example is how do you solve systems of nonlinear systems? So we're trying to find an x and a y that satisfy both equations. And we can do this by hand, and we can check the answer with a graph. So this is a nonlinear system because the first equation is not linear, it's a square root. The second equation is linear, but the way we solve this is by substituting this x plus 5 in place of x. I'm sorry, in place of y, because y is equal to x plus 5. We write x plus 5 in terms of instead of y. And this now turns into a square root equation that we could solve by squaring both sides. On the right side is really simple. The square root and the second power undo each other. On the left side, we get x squared plus 10x plus 25. A quadratic equation, we solve it by moving all the variables and numbers to one side. I'm sorry, this is supposed to be 17. I miscopied that. It's supposed to be 17, not 7. So on the right side, we get 0. On the left side, we're going to get x squared plus 6x plus 8. This is going to be done through factoring. Two numbers are multiplied to 8 and add up to 6 are 4 and 2. And the solutions here to these equations are -4 or -2. Now we are solving a system of equations that has two variables, so therefore we have to find an x and a y. But notice how we have y equals x plus 5. And that's of course the easier equation to substitute in. So the first thing is I'm going to do, first time I'm going to substitute -4 for x. And that tells us y is 1. So when x equals -4, y is 1. Second time around, I'm going to substitute -2 here. And we're going to get -2 plus 5, which is 3. So when x equals -2, y is 3. So these are the two solutions. -4, 1, and -2, 3. Because this is a system of equations, we need an x and a y. Now I'm going to show you how we could verify this answers graphically. So go ahead and pause the video if you need to watch and make sure you understand each of these steps. But this is what the graph looks like. Notice how I already have pre-typed those two equations. Y equals a square root and y equals x plus 5. So all we have to do is graph them. We knew that that's the graph of an equation that looks like y equals. And then if we graph the next one, which is a linear equation, it's a line. We notice that these two graphs intersect at 2 points, and these 2 points are exactly at -4, 1, which is one of the solutions, and -2, 3, which is our second solution. I hope you understood this equations, this problems, these examples. Keep reviewing, keep doing your best. Thank you.